Hello everyone, let's look at LeetCode problem number 752, open the lock. So in this question, we are given a number lock which looks something like this, and the digits or the present combination of the lock is represented by a string. For example, for this lock, the string will be represented by 8, 8, 6 and 5. What we have to do is that the lock initially is set as this string, and in one step we can roll the dial of the lock, that is we can increase it by 1 or we can decrease it by 2. And also it is rolling, so when we decrease it, if it's from if it's like 0 0 0 0 and we want to roll it backwards, so it will become 9000, or for the if we increase it, it will become 1000. For in one step you can increase one digit or you can decrease one digit in the combination. Okay, so now what we have to do is find the target. So for example, if the password of the lock is 1234, then we have we have started from here. We have to find out minimum number of steps, that is minimum number of rotations required to reach this goal. So we can say that this is one state of the lock. We want to reach this goal state with minimum number of steps. Also, if we look at the question, we are given here a list of dead ends, which means that if the block displays any of this code, the wheel of the lock will stop turning and you will be unable to open it. So we have to avoid the dead ends. For example, if okay, let's look at the LeetCode example itself. You will understand it better that way. So where is that? Okay, so now we are given this example. In this, the dead ends are given as this, and this is our target. So if we start from 0 0 0 and we have to reach to 0 2 0 2. So what you may think of is, we can increase this by 1 0 1 0, so that's one step. In the second step, we can go to 0 2 0 0. In the third step, you can go to 0 2 0 1. And but here we have reached a dead end, as it is present in the dead end list, so we can't move the lock from here. So what we can do is, we can increase this one first and then later this one, and in future we can decrement it by 1, which will cost us additional step, but we will reach our goal. So let's make it 0 2 0 0. Now let's make it 1 2 0 1, and then 1 2 0 2, and then finally we reach our goal of 0 2 0 2. So if we count how many steps we required is, here we required one step, here's 2 3 4 5 and 6 steps. So total 6 steps were required. That will be our answer. For this particular case, this is the minimum number of steps, but we have to find the minimum number of steps required to reach here, as you can also like increase it another by 1 and then decrease it and finally reach to this state, but we have to find the minimum number of steps required to reach the goal state. Okay, so now let's look at the approaches of this problem. The one of the approaches which I thought was using BFS, and BFS will work here, as BFS is optimal while DFS is not optimal. So what I'm saying is that if we start from this state 0 0 0 0, so from every state we have 8 possible outcomes, that is we can increase this dial or decrease this dial, so it has two choices. It also has two choices, increase or decrease. It has two choices and it has two choices. So what we are left is total 8 child states, or we can say that we are left with total next 8 states. Okay, so let's see for this 0. Okay, so now let's see this 0 0 0 0. So from here we have 8 states possible. So what I am doing here is making the state space. State space is nothing but the set of all possible states. Okay, so like this is our initial state. One of the state will be 1 0 0 0 1 sorry 0 0 0 0. No, we will like make it in pairs. So one of the state from here will be 9 0 0 0 as we decrement it. Then this will be 0 1 0 0, and second state will be 0 9 0 0. If we roll it back, then 0 0 1 0 and 0 0 9 0. For this one we will have 0 0 0 1, and if we roll the dial back, so it will be 0 0 9. Okay, so as you can see there are 8 possible different state possible. Okay, so now as we have generated these states by our initial state, okay, so now we will call the functions over these states, and these 8 states, these will again generate 8 state, again 8 states, again 8 states. So this will be 8 8 8 8 8 8 8. But we don't have to explore all these, as we have reached to a state which is either the dead end. We have to stop here, we cannot move further from it, so we will have to backtrack from there. Okay, then if we have already visited a node, or if we are already visited the node, then we don't need to explore it again, so that will also save our time. Okay, so let's see how many states are possible here. How many possible states? So the combination is made up of 4 digits, and each digit has total 10 values. How come 10? So it's from 0 1 2 3 4 5 6 7 8 and 9. So these are total 10 values possible for any digit. So it has 10 values possible, it has 10, it has 10, it has 10. So total number of states will be 10 to the power 4. Okay, so if we do BFS or DFS, so we will end up saving these number of steps either in the stack or in the queue. Okay, so let's, if we see at the constraints are okay, as we have given the, okay, so there's no problem in the constraints, as it's only 10 to the power 4, so there's no more possibility if there are only 4 states, so that will be okay. O of n space will work here. So okay, now let's look at the let's look at the BFS solution. And also one thing to note here is that we cannot find the answer through DFS, because as we expand from here we will get different states. Like here will be 8 states, here will be 8 states again. So what DFS will do is, first it will explore this child, then it will explore this child, then this one, then this one. It will move to the left hand side, and then when it is exhausted and it doesn't find any solution, then it will move up. So if by any combination, let's say we find a goal state here, we have find the goal state here, and from this particular case we have find the goal state here only. So the DFS function will move here and will return the depth of this solution. So it will always be more, that it will not always be more, but in this case, when the goal state is here and the goal state is here, if we go from this path, then DFS will expand these nodes first, and as soon as it finds the goal node, it will return this. So it will not be optimal, because this length, this depth is more than this depth. This is our minimum answer. We have to return the minimum possible steps. Okay, so that's why we are using BFS here. Let's see how can we use BFS to solve this problem. So as I have told you in earlier videos, that BFS is optimal. It gives the shortest path, so it will always return the minimum number of steps as it reaches the goal state. So let's see the example here again. We have our initial goal state as 0202, and this is our dead end list. Okay, so let's move it down in the current slide. Okay, what we will do is we will call the we will make a queue. Let's say this is our queue, and here we will push initially the current state, that is 0000. Okay, and we will expand, or we will explore each state, that is the current state is 0000. So we will make a for loop over this current state, and for each I we will increase it by 1 and decrease it by 1. We will handle the negative, that is going negative and turning it to 9 part later in the pseudocode. But let's understand what I mean by rotating it once and rotating it backwards once. So the first state that will be generated is 1000. Okay, so now as 1000 is generated, it will be pushed into the queue 000, and it will be marked as visited. We'll also have to make a visited array here. Now the next state that it will generate is 9000, as it will decrement, and now our queue will contain 9000. Similarly, the queue will now contain all of these children, or we can say all of the numbers that can be generated from this. So the queue now will contain 0100, and it will contain 0900, then it will contain 0010, then it will contain 0090. It will now have 0001, and finally for this current state it will have 0009. Okay, so that was our initial route, that why it was inserted, but while exploring its neighbor it will be popped, and now this will be our queue here, and next we will pop this 1000 from the queue. So now 1000 is our current state, and it will also generate 8 childrens. Okay, but the thing is that they must not be visited earlier, so the first child will be 2000, but if we see the second child, that will be 0000, as we will decrement this, so it will become 0, and it is already visited, so this will not be pushed into the queue. We will only push this into the queue. Okay, so now our queue will have 2000, and if we now see the other childs, so they will be generated as they will have a leading one and then the rest of it. So let me directly push it into the queue. So now we have popped this one and we are exploring its neighbors. So now our queue will contain 110000, 1900, then 1010, then 1090, then 1001 and 1009. Okay, so we will explore all of these neighbors of each node until the as we find the target, as we pop something from the queue, and let's say our target was this will take a lot of time for the dry run. So let's say if our target was just 0100, so as we pop this from the queue, we will say okay, 0100 is our target, so we must return the depth here. Okay, so our queue should be containing the depth of each state. So we will use a pair class, or you can use another class, making a custom class. So I will use a pair of string and int. So here the string will represent the combination, and a integer here will represent the depth. Note that you can also represent this string as an integer by converting the string to an integer. That will also take less space, but for simplicity, let's not go there. We are using it as string only. And also, if you convert it to integer, that will be a faster solution to this problem. Okay, so now let's look at the pseudocode. So our first function is the openLock function. OpenLock, which has parameters as deadend and the target. So for checking deadend for each state, you can make a map, or you can use the contains functionality. So we will make a visited array, visited, and it will be of type say string comma bool. We are not using a visited as array here, we can use it as a map. So let's use an unordered map, unordered map, and say string and int, sorry, string and bool. So what each entry will tell us is that this string is visited or not. That's why using a bool here. Okay, so now initially all the strings will be false. So first we will make our current state. So let's say that we have a current string current is equals to 0000. This is our current string, and then we will make a queue for doing BFS. So queue, and as discussed in the approach, its type should be pair of string and int, and this string is the combination, and the int represent the level or steps reached to that combination. So let's name the queue as queue only, and now initially we should push our current into the queue. So what we'll do is queue dot push, and we'll push here current comma the steps required to reach that state. So initially we are at 0000, so we don't require any steps, so we will push 0 here. So current comma 0. You can use the make pair function here as well. Now we will just pop one element from the queue, explore all of its neighbors, and if the neighbors are target, we will return the answer, or if the neighbors are already visited, we won't push it into the queue, else we will have to push it into the queue for further exploration. Okay, so now let's make a while loop. While queue dot empty, queue is not empty, sorry. Then we will pop the current or the front from the queue. So let's name the front as current state. So we will have a pair string comma int, and we will say it current state this will be q dot front. Okay, so now we have taken the front from the queue. We'll have to pop it, so q dot pop. And now our current string will be the string or the combination that is in the current state. So we'll say current state dot first. Okay, and now let's the level or the steps will be, let's say it level will be current state dot second. Okay, so now we have the current state, so now we will have to traverse all of the neighbors. Okay, so now we'll have to traverse all of the neighbors of the current state. Okay, so let's just zoom it, and now we will traverse all the neighbors. Okay, so we will use a for loop here. For int I is equals to 0 and I less than 4. As we know, the size of string is always 4, so I less than 4 and I plus plus. We will have two strings which we will get from two functions, which I will tell you. So the first function will be the increment function. It will take two arguments, the current string and the I, the position in the combination that we are increasing. And let's say the string is forward. Okay, so forward will have a string which is incremented from I. So let's say if our current state is 0 1 0 0 and we send it to increment function, increment 0 0 0 0, and we say I is equals to 2. So our I will be 2 here, so we are talking about this one, and this will return 0 1 1 0. It will increase it by 1 and return it. Okay, so we are just using two functions to make the moves. Okay, our second string will be, say, backwards. We move the dial backwards, so it will be decrement and it will be current comma I. Similarly, it will decrement the dial value. Okay, so now what we will do is check each of these. So if the forward is not visited, if is not visited forward, and we also need to check if it's not the dead end. So and is not dead end dot contains forward. It should not contains forward. Okay, so if this is the case, then we will push it into the queue. So queue dot push, we will say forward. And the important part here is we will increase the level by 1, as this is the child of a state with level say 2, then his child will have already a level plus 1, that is 3. Okay, so we'll push it, and now we can check it inside this if condition only. That we can also check it here also, that if forward is our target, then we must return it. So let's check it here only. So we'll move it down and we will say that if the forward equal to target, then we must return target. So return target. Okay, now we will check backwards. So say if backward equal to target, then we will return we will not return target, but we will have to return the current level. So we will return level plus 1 here, and we will also return level plus 1 from here. Okay, and now if it is not the target, then we will again see that if it is not visited if the target, if the backward visited, and here we will say backward, and also it should not be in the dead end. So is not dead end dot contains our backward. So we will say backward, and if it is not, then we will q dot push. We will push our back, this backward state. So that will be backward comma level plus 1. Okay, so now as we have explored all of its neighbors, as you are saying that for each I we are checking its both the possible child. So for 0 1 2 3, let's say this is our state. So for this position we are checking its true child, for this position 2, for this one 2, for this one 2. So we are checking all the 8 possible children for each state. Okay, so now we will close our for loop here, and we will also close our while loop here. So as you can see that in this function we have seen this: if we find the of that are at any point target is equals to our forward, or we find that our target is equal to our backward, so we are returning the level. And if we don't find such forward, okay, if we don't find such forward, what we will have to do is at the end we will return 0. If it is not returning from there, it means that we have explored all the possible states where we can go, and now we don't find an answer. So we'll return -1 as mentioned in the question. Okay, so that was the pseudocode of this problem. It was really interesting problem, and you can see how LeetCode is teaching us to pick locks. Okay, so